This is our summary sheet on graphing rational functions, and I think this single handwritten page has everything you need to know to graph rational functions on it. So it's the main summary. So if some of the explanations don't, work for you, or there's too much discussion, this sums it all up right here. This is what I want you to be able to do, and you can use this guide to help you graph rational functions. So I want to just walk us through these steps of the sheet here. So a rational function is of the form p of x over q of x, where p and q are polynomials. They will always be reduced for us, so we will not have to deal with the situation where they are not reduced. And so what do you do? And this is how you get started with graphing. First, you're going to check for vertical asymptotes, which I will sometimes write now as VA. And what you do is you set the denominator equal to 0 if P over Q is reduced, and it will be for us. Now, when you find those vertical asymptotes, you could have 1, you could have more than 1, you could have 0 vertical asymptotes, but around each vertical asymptote there are 4 possible shapes for the graph, and that will need to be determined before you're through. You may need to evaluate the function on each side of a vertical asymptote to decide which shape to choose. Also, I wrote this sideways just to squeeze it in here. You might not be able to decide this until after steps 4 and 5. So you know the location of the vertical asymptotes right away, but the shape of the graph may be something you figure out later on in the procedure. Step 2 is to check for horizontal asymptote. There's never more than one horizontal asymptote. Sometimes there's none. And so we'll denote that HA for horizontal asymptote. If the degree of the numerator is greater than the degree of the denominator, there's no horizontal asymptote. If the degrees are equal, there is a horizontal asymptote, and the equation is given by y equals the lead coefficient of the numerator over the lead coefficient of the denominator. If the degree of the numerator is less than the degree of the denominator, then the x-axis, whose equation is y equals 0, is a horizontal asymptote. I think you should also always plot the x and y intercepts, if any. So you set x equal to 0 to find the y-intercept. There would be at most 1. Set f of x equals 0 to find the x-intercepts. There could be many. This is going to be the same as setting the numerator equal to 0 as long as the fraction is reduced, so that you can think of as a shortcut way to find the x-intercepts. Again, there might be none, there might be a lot of x-intercepts. Step 4, we will see in our examples now. Now we haven't seen this yet if you're following these videos in order, but we will see this in later examples. You have to check to see if the graph crosses the horizontal asymptote. And what you do is you set f of x equal to the horizontal asymptote value and solve for x. So it is possible for a graph to cross a horizontal asymptote, and we want to find those points. Because once we label them, we know the graph cannot cross the horizontal asymptote at any other points. By the way, a graph never crosses a vertical asymptote. That's absolutely impossible. Vertical asymptotes represent values of x that are not in the domain, so there's no point on the graph that corresponds to them. And point number 5, I say it's always okay to plot a few more points. That may help you figure out the shape of the graph, especially around the vertical asymptotes. And finally, I have a checklist on here. Does your graph approach the horizontal asymptote as x approaches infinity and x approaches minus infinity? That is, if there is one. Does your graph include points for all x in the domain, for all x except where vertical asymptotes occur? I sometimes have students who leave big gaps on their graph, and it's like the only place there should be no graph is at a vertical asymptote. All other values of x should have a point indicated on the graph. And does your graph satisfy the vertical line test? I've also had students who draw a graph that kind of loops back on itself and does crazy stuff, but these are functions. So your graph has to satisfy the vertical line test in the end. Finally, we will not cover what are called slant asymptotes in this course. If you want to know, you can just send me an email about it and I'll talk to you, or we can communicate other ways. I'm not going to cover slant asymptotes at all, which you do see a little bit of in the textbook. So that's our summary sheet, which is posted as a PDF in Canvas, so you can print it out if you'd like. And so we're going to do some pretty detailed examples in the coming videos now where we work through all these steps.